Alright guys, so today we're just going to continue our conversation about standard form of linear functions. Some of you started taking these notes yesterday, so I want to just quickly read over it. You guys please feel free to pause this and copy down these notes in your notebook, and then we will work on the graphing part on the little booklet that I gave you. So what are standard form of linear functions? Standard form is when you have your x and your y. In this case, you have your independent variable and your dependent variable, x and y, all on the same side of your function, and then you have the constant on this other side. A couple of rules though for standard form: we cannot have a fractional coefficient, and your coefficient of x, a, cannot be negative. So for example, going down here, something like this would be standard form. If you ever get something like 0.3x plus 0.4y is equal to 1.2, well, right there, that breaks the rule. I need to multiply everything by 10 inside here, because multiplying everything by 10 will allow it to become 3x plus 4y is equal to 12. The only reason why is because it just makes standard form is when your coefficient attached to x, soon we'll talk about that being the y-intercept, it has to be a whole number and it has to be a positive. We'll explain more about that in class over the next couple of days about why and how various forms of how we can make it positive if it is a negative, and how we can make a whole number by, as you can see, we just multiplied everything by 10 or whatever you need to multiply by to make that coefficient of x whole. All right, so let's move on to actually how to graph using standard form, or and how to graph standard form and change standard form into slope-intercept form. Okay, so yesterday before I left, I gave this out. If you need extra copies of this will be on my desk. Feel free to grab one. Please pause this right now and copy this down on the front of your booklet, and then when you're ready, push play, and I will explain in detail method 1 and method 2. I'm not forcing you guys to do one or the other, but I do want you guys to feel comfortable doing both. The first method is converting your standard form from ax plus by equals c into slope-intercept form. Method 2 is kind of what we practice in class. Find the x-intercept, the y-intercept, and then plot those points on the graph. You know that the y-intercept sits on the y-axis, the x-intercept sits on the x-axis. Once you have those 2 points, like anything else, you have those 2 points, you can connect those 2 points and build your function from there, find your slope, and go from there. All right. So step 1 for converting into slope-intercept form, if you have your positive whole number ax, you move it. You do your additive inverse and you move it to the other side, and then you divide both sides of your function by b, and you should and then you'll be able to get your output, or your dependent variable y by itself. Okay, so anyways, pause it, write these notes down, and when you're ready, push play. Well, I will continue on. So here we go. So example 1, this is an example that we did yesterday. I'm going to focus on method 1. So method 1, here is my standard form. 3x plus 5y is equal to 15. The first thing I need to do, here is my ax, right? Because standard form is ax plus by is equal to c. Oftentimes you write it as ax plus by is equal to c. First thing we need to do is, this is a positive 3x, so we needed to move it to the other side by doing its inverse. Remember that we cannot take away 3x from 15. This goes away. I have 5y is equal to 15 minus 3x. Divide both sides by the constants of b, or the coefficient of y, which is 5. And here I have y is equal to 15/5 is 3, just dividing that. And then I'm going to divide negative 3x by 5, which is my rate of change, which is negative 3x. Or some of you feel more comfortable doing plus negative 3x. Remember that since it's negative 3x over 5, as long as one of your terms is negative or one of your numbers is negative, the entire rate of change is negative. And there's my slope-intercept form. I have y is equal to 3 plus negative 3/5 x, or y is equal to negative 3/5 x plus 3 for those of you that are feeling more comfortable with it being in y equals mx plus b. Okay, even if you get y is equal to negative 3x over 5 plus 3, that negative 3/5 of x, negative 3x over 5, those are all the same. So there's my y-intercept. My y-intercept is 3, so there's 3. My slope is negative 3/5. So that is 1, 2, 3, a run of negative 3, and then a rise of negative 3, rise over run there. Sorry, Mr. Wynn. I had a little mishap right there. It's a change in y and change in x. So it's down 3 and run 5. 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. Going the opposite way, up 3, 1, 2, 3, and then run left 5, 1, 2, 3, 4, 5. It's the same thing. And there's my function. You can connect it if you want. Okay, you can keep going. Up 1, 2, 3 to the left 5, 1, 2, 3, 4, 5. And there is the form of y is equal to 3 minus 3x over 5, which is the same as saying 3x plus 5y is equal to 15. This should look familiar because all semester long I've had you guys isolate a standard form or isolate where x and y are on the same side, and I had you solve for y or trying to get you to get y by itself. Well, there we go. The reason why I've been slowly having you guys do that is actually changing standard form into slope-intercept form. All right. That's method 1. Let's go to method 2. Feel free to pause the video, and if I'm going too fast, rewatch it, write down questions, and we'll go over in class when I come back. All right, let's go to method 2 here. Method 2. All we got to do is, for method 2, is if you have your standard form, find the x and y-intercept. A couple things. I know that the x-intercept is when y is 0. So I have the x, and then I have 0. The y-intercept is when x is 0, and then I have the y value. So if I know that the x-intercept is when y is 0, I can actually substitute in 0 for the y. So this is what I would do. 3x plus 5y is equal to 15. I take this 0 right here and I put it in there. And I actually solve for my x value. So I get 3x plus 5 times 0 is equal to 15. Anything times 0 is 0, so I get 3x is equal to 15. Divide both sides by 3. X is 5. What does that mean? That means my x-intercept is 5, 0. There's my first point. I literally just use 0 for y. I put it in there and I solve for the x-intercept. Next, I do it again. I know that the y-intercept is when x is 0, so my function is 3x plus 5y is equal to 15. This time I take the x is 0 and I put it in for, I substitute it in. So I get 3 times 0 plus 5y is equal to 15. Anything times 0 is 0. I have 5y is equal to 15. Divide both sides by 5. Y is equal to 3. So my y-intercept is 0, 3. Now that I have these 2 points right here, solved it algebraically for the x-intercept by putting in 0 for y, solved the y-intercept by substituting 0 in for x, I can plot those 2 points. 0, 3, right there. X-intercept, x-intercept. It literally sits on the x-axis right there. What can I do with these 2 points? Well, I can find the slope. And the slope is down 3 to the right 5 from each other. If you don't believe me, we can actually just stack the 2 points on top here. Here's x, y, 5, 0, and that is minus 3 plus 5. My slope is negative 3/5. And once I have that, I can just keep graphing negative 3, 1, 2, 3, and run 5. Or I can go opposite, up 3 and go 5. And there's my function, up 3 and over 5. And there is graphing standard form by using the 2 intercepts. Yesterday's activity where I had you guys try to make the equation true by substituting in numbers for the x and y intercept to find the intercepts, that's basically what we're doing here. And you notice right away both methods work. One, you actually substitute in 0 for y to find the x-intercept. The other one, you substitute in x for the y-intercept. That's method 2. Method 1 is you literally just isolate the standard form for the variable y, which allows for your output, and you can tell that I have the same rate of change, the same y-intercept for both, the same x-intercept for both. Okay? And then I want to look at this one real quick. Right away, you can tell that this is standard form and slope-intercept form. The only hiccup for this problem that I found was I wanted to show this to you guys. Oftentimes, when they show you this is already breaking the rule. This is not standard form because look at this number right here. It is a negative 3, which means we need to, if we wanted to rewrite this as true standard form, negative 3x plus y is equal to 2. This is not standard form because this number needs to be positive and a whole number. Well, luckily, it's already 3. We just need to make it positive. So I would multiply this whole thing by negative 1 and distribute this negative 1, and I get positive 3x minus y is equal to negative 2. It's just a little formality rule. It makes it the same function. It doesn't change. These two are identical. They're the same. If I were to graph them, they will be on the same line. Since this one, the constant or the coefficient of y is already 1, or in this case negative 1, I can just do, I'm going to do method 1. Subtract 3x, subtract 3x. I get negative y is equal to negative 2 minus 3x. I am going to divide by negative 1, and I get y is equal to 2 plus 3x. And you can tell that I really didn't do much. I just moved 3x to the other side from the beginning. So there's my function right there. 2 is my y-intercept, and my slope is 3x. So up 3 over 1, down 3 over 1, and there is my function. Okay, and this one, it is hard to find the x-intercept because it is not exact on the graph, so we would have to solve it for it algebraically. Okay, so pause it, take notes, rewatch it if you want, slow it down, write down questions, start the book work, and then we will definitely go over this in class tomorrow. All right, thank you guys.